Alright everyone, welcome back. We're in section 5.5, which is going to be dealing with permutations and combinations. This is the last section in chapter 5 that we'll be dealing with. There are more sections that we're going to skip, but let's get into this one. So here's our first example. 4 people run in a race. In how many different ways can they finish the race? So how many different ways can 4 people finish differently? We can use that, sorry for the scribbles here by the way, but we can use that multiplication rule that we were looking at in the last section to answer this question. How many ways are there for us to choose the first place winner? And how many ways are there for me to choose the second place winner? And how many ways are there for me to choose the third place winner? And on and on and on. One thing to keep in mind this time is that once a person has been chosen for first place, that same person can't be chosen for the second place. So the number of different choices is going to go down like so. Overall, there are 4 people to choose for the first place winner, 3 people to choose for the second place winner, 2 people to choose for the third place winner, and that leaves only 1 person left to finish last. There are 24 different ways for the race to go. Okay, this is a rather easy example of a general idea in math called permutations. In math, a permutation is an arrangement or an ordering of a certain number of objects where replacement or using the same object twice is not allowed. So this is a bit different than some of the license plate problems that we were looking at in the last section, where we could pick the same letter more than once. Here we're imagining that we can't pick the same object or use the same object more than once. So what if we did the same problem with a little bit of a twist? What if 8 people were running the race? How many different ways can 8 people finish? First, second, third, fourth, fifth, sixth, seventh, eighth? Well, same idea. We have 8 choices for the first place finisher, then 7 choices for the second place finisher, then 6 choices for the third place finisher. Remember, why 6? Because 2 people have already crossed the finish line, so there's only 6 people remaining to be chosen for that third place finish. Altogether we multiply and we get 40,320 different ways for a 8-person race to finish differently. You can kind of see what's happening here. You know, if there were 10 people running, then we'd have 10 times 9 times 8 times 7 times 6 on down to 1. If there were 20 people running, we'd have 20 times 20 times 19 times 18 times 17, on and on and on. In general, there's a general principle going on here. In general, the number of permutations of n objects is given by this symbol right here, n with the exclamation point. It's pronounced n factorial. And the formula for factorial is n factorial is calculated just by starting with the number n and then multiplying by n minus 1, the next smallest whole number, and then n minus 2, and then n minus 3, all the way down to 1. Multiply by all the integers from n down to 1. By the way, this is something that's going to come up later. Don't worry about it too much now, but we define 0 factorial to just be the number 1. Don't worry too much about it. Just nod your head. Say, okay, this is mainly to get the formulas to work out for some special cases down the road. Okay, let's see some examples. So let's say that I have 10 different books on my shelf, or I have 10 different books, excuse me, and I want to put them on my shelf. In how many ways can we arrange those 10 different books on my shelf? So I'm putting them all in order. How many ways can it be done? Well, you could do it the way that we were doing it last time, where we had 10 times 9 times 8 times 7 dot 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 dot. That's all summarized by just saying 10 factorial, and 10 factorial, that product comes out to 3,628,800. By the way, there's a way to speed things up and use your calculator here. Punch in the number 10, and then in my TI calculator, I'm going to go to the Math menu. I'm going to go over to the probability menu, and then you can see that exclamation point down there in option number 4, 10 factorial gives me 3,628,800. Okay, save you some multiplication right there. All right, so little twist here. What if we didn't want to arrange all 10 books on my bookshelf, but what if I only wanted to pick 3 books and put them on the bookshelf? Well, it's not too difficult here. In how many ways can I arrange 3 out of the 10 books? Well, I'll have 10 choices for the first book, and then 9 choices for the second book, and then 8 choices for the third book, and that's where I'm going to stop. I don't want any more. That's 720. There is a math formula that we could use here. In this case, this is called like a partial permutation, but the number of permutations of R objects taken from a total of N objects is, here's the notation that we're going to use, the permutation of R objects taken from N objects. So N is the total and R is the number that we're taking out of that total, is given by this formula, n factorial over n minus r factorial. Let's see how that works out for the last problem. So in the last problem, the total would be 10, so that's my n. The number of books that I'm choosing and then ordering, that would be 3, so that's my r. Look at what happens if we plug in 10 for n and 3 for r, then we get 10 factorial up on top. We get 10 minus 3, which is 7 factorial down on bottom. And look at what's going to happen. 10 factorial means I'm multiplying 10 all the way down to 1. 7 factorial means I'm multiplying 7 all the way down to 1. And I have a whole bunch of cancellation that takes place. The 7s can cancel, the 6s can cancel, the 5s can cancel. The only thing that's left is going to be the numbers that I want to stay, 10 times 9 times 8, up in my numerator, which is 720. Okay, so this formula right here does the same thing that we were doing with that book problem. It cancels out everything except those first 3 numbers that we want to stay. 10 choices for the first book, 9 choices for the second, 8 choices for the third, would be a total of 720. Okay. So, let's say that we have 8 people running for positions in a local school board. In how many ways can the president, vice president, and secretary be chosen? So I need to pick 3 people from the 8, and order matters. This is going to become more and more important because we're going to see a formula in just a little bit that calculates the number of ways that I can pick things from a group if order doesn't matter. But for permutations, the order does matter, whether it's the order that people finish a race or the order that I place books on the shelf. In this problem, the order refers to which person gets placed in the president's position and which person gets placed in the vice president and which person gets placed in the secretary. If we choose the same 3 people out of the 8, but we place them in different positions, that's a different result. And so the order of placement matters. 8, that's my total, that's my n. The number of people that I'm picking out of the 8, that's my r, that's 3. I'm going to use that permutation formula, the permutation of 3 objects taken out of 8 objects. 8 factorial over 5 factorial comes out to 336. Now you could do this on your calculator. You could have 8 factorial divided by 5 factorial to get 336, or there's another function on my calculator that might come in handy. What we're going to do is put 8 in first, go back to that same probability menu under the math button, but instead of going all the way down to the factorial, go down to just the second option, the permutation option. The way the calculator wants you to enter this is first enter your n, we already did, that was 8, then enter in this permutation symbol, and then enter in r, which is 3. gives me the same calculation without having to do the factorials. Okay, let's see. Is that it for this section? Or, yep, that's it for this section. Let's stop right here, and then we're going to pick up the next formula, combinations, in the next video.